Okay, this is 2.4 homework help. First problem says that we want to match these piecewise functions with their graphs. So let's look at the first one. It's the first one's a line, y equals 3. Y equals 3 is a horizontal line for whenever x is less than 2. And then it's another line with a slope of 1. So we're looking for a line with a slope of 1, and there's there and there, but it has to be this one. I know this is really hard to see, but the first one's a line at 3, horizontal line, for x is less than 2, and then at 2, it turns into a line with a slope of 1 and a y-intercept of -1, which would be this line. So that would be D. Next one is a line. We're looking for a line for whenever x is less than -2 that has a downward slope and a y-intercept of 1, so that'd be this one, obviously. And then 4. So then it's the line y equals 4 the rest of the time. So that'd be C. The next one is y equals 2 for whenever x is less than or equal to -1. So that'd be this horizontal line. And then it's a parabola after that. And then the last one, it's a line with a slope of 2, which is obviously this one, and then it's another line with a negative slope. So it'd be A. Okay, next one wants to find an equation for this parabola. We have this on our formula sheet, which is vertex form for a parabola. I think this is the easiest way. If the vertex is at -2, 3, it gives us h and k. So it'd be y equals a times x minus h, which is -2, and then plus k, which is 3. Now they give us a 0.01, so first of all I can make this positive. And then plug in the 0.01, so 0 goes in for x and 1 goes in for y, and that helps us find a. So when you do that, you get 2 squared, which is 4, so you get 4a plus 3 equals 1. Subtract 3 from both sides, gives you -2 equals 4a. Divide both sides by 4, and a equals -1/2. So that'd go in here, -1/2. And then h is -2, so this would be +2, and k is 3. So there's our function once we plug a, and h, and k back in. There's our parabola. All right, next problem is another domain question, which I know we've been doing these, but I kind of, to be honest, put this in for extra practice. So we're looking for the greatest value in the domain. So we want to factor the bottom, and we get x plus 7, x minus 3. And we know that that has to be positive. It can be 0, but it's got to be positive. The bottom can't be 0, which we'll look at, but this quantity, we can't have negatives on these square roots, so this has to be positive. So when we did these problems, we made a sign chart. We put the key points on there, which in this case, the key points are the places where this is undefined, which would be -7 and +3. And we tested to see what the functions are like to the left of -7, like plug in -8, you get a negative in the bottom, and then, so 1's positive in the top. Negative there and a negative there makes positive. Okay, and then try them between -7 and 3 like 0. When you plug in 0, this gives you a positive there and a negative there, so that'd be negative. Plug in a number bigger than 3 like 4, and you get a positive and a positive, so that'd be positive. So the question is, when is this thing greater than or equal to 0? First of all, these are undefined points, and that's important. So you can't use those. So when is this thing positive? Well, it's positive from here all the way here, not including this point, and then also this direction, not including 3. So that would be, well, the domain would be -infinity all the way to -7, as well as 3 to +infinity. But they don't want us to give the domain, they want us to give the largest value in the domain. Or I'm sorry, largest value not in the domain, which would be just, it would be 3. 3 is not in the domain, and that's the largest value not in the domain. Okay, next question wants us to find all the real values where this equals 0. So we're looking for the zeros of this quadratic. So we have some tools for that if you recall. Plug in 0 for y, and I'm going to factor out a -4 from this, and that leaves me with x squared minus x, and then -5. Just double check that. Yeah, that works. Okay. So actually this would be plus x right here. Okay. Now, I would factor this if we can, but I don't think there's anything that factors that multiplies to be -5 and adds to be 1. So unfortunately, this doesn't factor. We're going to have to use the quadratic formula. Basically, we're looking for where this is 0, because where this is 0 gives us 0. So the quadratic formula works great. It's the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Looks like we have some irrational answers. If all negatives go positive, this is 21 underneath here, all over 2. So it looks like our answers are -1 plus the square root of 21, all over 2. Make sure this gets in parentheses. As well as -1 minus the square root of 21, all over 2. These are the real values where this is 0. And we didn't necessarily need to factor out the -4. I could have did the quadratic formula without it, but these numbers end up being a little easier to work with, these coefficients. Okay, the next problem's pretty easy. It gives us this absolute value function, and it says that it wants to know if x is less than 1/2, which function is this equivalent to as far as a line. So if you just graph it, you can see that it's asking for this over here. It's asking for what line is this basically right there if it kept going. And that line has a y-intercept of 7 and a slope of down 2 over 1. So a slope of -2 and a y-intercept of 7. Okay, another domain question. Look at this function right here. This is the square root, so we know what's under here has to be greater than or equal to 0. It can be 0, but it has to be greater than or equal to. If I factor out an x, I get x squared minus 25. And if I factor this some more, I get x minus 5, x plus 5. And now I can make a sign chart listing the key points, which is -5, 0, and +5. Now these are 0, so these are okay. I can include those. And we need to test to the left of -5, which would be -6. It could be a negative, and a negative, so that'd be negative. And then it probably alternates, as you would think. -1 would give you a negative, and a positive. Yep. So it'd be positive, negative, and positive. So if you test those intervals, then you can see that when this thing's greater than or equal to 0 is from here all the way to here, as well as from here all the way up to positive infinity. So we would say -5 to 0, including those points, as well as from 5 all the way up to positive infinity. Now that's the domain. It didn't ask for the domain. It actually asked for the least, what's the least value in the domain. So the least value in the domain would be that value right there, which is -5 for me. All right, next problem is x squared minus 256 in the bottom here. That has to be greater than 0. It can't be equal to 0 either. I'm sorry. This cannot be equal to 0 only, because a 0 here would give us an undefined value. So let's find out when it is equal to 0. You add 256, you get x squared equals 256. Square root that, you get x equals plus or minus 16 are our problem areas. We can't have x be those areas. So in interval notation, we would say -infinity all the way up to -16, not including -16, as well as -16 to positive 16, not including either, and then 16 to positive infinity, not including 16. So there's our domain in the interval notation. All right, next problem is just good practice with function notation. Wants us to plug in 1. 1 gives us 1 times 3, and then -2, and you just get 1. Plug in t, you just get the function back basically, but with the variable t. Plug in x squared, and you just get 3x squared minus 2. And if you plug the function into itself, then you have 3 times, then plug the function in for x. And you can simplify that a little bit. That's 9x minus 6 minus 2, which is just 9x minus 8. Okay, a little more practice with function notation. F of 9, 9 times 5 is 45, plus 5 is 50, so we have 50 plus f of 6 would be 35. And you add that together, you get 85. And then it wants us to do f of 9 plus 6. 9 plus 6 is 15, And if I plug in 15, I get 5 times 15 plus 5. 5 times 15 would give you 50 plus 25 is 75 plus 5, which is 80. So this would be 80. More practice with function notation, so plug in x minus 1 in for wherever there's an x, and you just have to do some FOILing here. So it takes a little bit of time, but we can simplify this. So x minus 1 cubed gives us, well, first do x minus 1 times x minus 1. Maybe you want to do this separately here, but you get x squared minus 2x plus 1, and you still have to multiply that by x minus 1. So when you do that, you get x cubed minus x squared minus 2x squared plus 2x, and then plus x minus 1. And we can add like terms together to get x cubed minus 3x squared plus 3x minus 1. So I added these and these together to get this. Now that's right here, so now I'm going to just move this back up for you if you don't mind. Plus 3x minus 1 goes there. Okay, so then I need to do the next term now, which is right here. X minus 1 times negative 2, so I'm going to do that right here. X minus 1 times x minus 1 gives you x squared minus 2x plus 1, but I still need to multiply that by negative 2. So that would give me negative 2x squared plus 4x minus 2. And that goes here. Then I still have the rest of it, which is right here. This is going to be plus 3x minus 3, and then plus 4. So now I'm just going to add like terms together. I'll look for any x cubes. I just see one, x cubed. I'll look for any x squareds. I see those and those, so that would be negative 3, negative 2, make negative 5x squared. I'll look for any x's, so x is there, there, and there. So that would be 3 plus at least 10x. And then I'll look for any numbers, so I have negative 1, negative 2, negative 3, and 4. So that would be 1, negative 1, so negative 2. So then I can go ahead and just enter these in. They want this to be 1, this would be 5, this would be plus 10, this would be minus 2. Next problem wants the domain of this function. Well, we know this has to be greater than or equal to 0, so we can subtract 16. We can divide by a negative 1, in which case this would give me x squared is less than or equal to 16. I have to switch the sense of the inequality. Now I'll take the square root, and what I find is that x has to be less than or equal to 4. I also find x has to be greater than or equal to negative 4. So if I graph that on a number line, x has to be all the points that are greater than negative 4 and less than positive 4. So I'm looking at this as my domain, all the numbers from negative 4 to 4. So I would say that, negative 4 to 4, and I can include those with brackets because they're included. I can have 0 in here. Now I need to look at the range. Now you can get the range pretty easily by plugging in like one of these endpoints, because that's the smallest and largest x can be. So if you do that, you get 0. So basically that means that the smallest the y value can be is going to be 0. The largest y value can be then when you're in the middle then, which would be if you plug in 0, you get the square root of 16, which is 4. So the largest you can get is 4. So the range is from 0.
Good morning, Eastern.
To 4, and you can include both those points. You can always look at the graph too to see that the range is from 0 to 4 if you'd like. Next problem with domain and range. Domain, you have to stick in positive numbers, so obviously x has to be greater than or equal to 0. You can stick in 0. So that'd be 0 to infinity, including 0. And then, if you think about it, 0 is the smallest number you can stick in, so the smallest y can be is 20. But you can stick in bigger numbers, so it's 20 to positive infinity, and you can include 20. Alright, the last problem wants the domain range of this piecewise function. I just graphed this because I'm running out of time, and you guys are going to have to learn how to graph these. So take your time, get a piece of graph paper and graph this. It's a line for all these values less than 2, and then it's this line for all the values greater than 2. So the domain's all real numbers, negative infinity to infinity. In set notation, in interval notation I mean. And then the range is all the values that are less than 4, so we'd say all the way up to 4, but negative infinity all the way up to 4, and not including 4, so parenthesis.